Yeah, Ballroom Blitz 6 here again. Ballroom Blitz 6 here again. Total materials. This is part of my class stuff. I just finished writing. But material engineering is making the stretch of material. Right at the moment in time, I'm not gonna go too far in details because I'm multitasking here, but basically what you're doing with is putting a combination under a certain process, a standard process, and using that combination over and over with different materials in a certain process. I'm going to talk about steel, iron, polymer, plastic versus plastic, hardwood, wood, and other stuff that deal with firearms and other stuff. You know, iron is come from ore, which is done by the process of smelting, which is separating materials from the raw materials from the process of ore itself and getting milled up and adding lime, quartz, or chalk and stuff like that to split the items up apart on it, basically. Now, that's smelting. Forging is when you forge that material into something else and get a higher purification of it. Polymer is a form of polymer plastic, which is a plastic, and plastic is a rising chains of monosaccharide chains come from plastics or plants or meat or sun stuff like that. And then wood, which is you gotta laminate it, which is using a glue on top of glue or some type of hardening glue in a specific pattern under specific pressure on a specific process to get lamination and polish it and do it again. You get a certain strength of it. Or engineer wood, which is basically just different kind of woods that been burned to ash, reprocessed, blah blah blah, and compressed in such a way that it's solidified. Usually, when you cut metal into a powder, you can solidify by putting a certain amount of psi's on it, and you get a hard metal, even though it is powder state in its powder state. Um, there are certain materials that are meant for certain things due to the process of it's made. It's not that difficult to test it. If you want to see how hard something is, hit it with your forehead or something. I know. Keep it simple. Or use and make a set standard that goes with that section. Other than that, that's not really much to talk about. It's the same thing for anything else. Or it can work in a certain environment, or it can work in a certain weather, so to speak, or under certain conditions. That's basically what material engineering does. That make the small stuff to make the small stuff and allow someone else to make whatever they want with it. Materials can range from anything from organic, like prosthetics, or heart pacemaker, or artificial hearts and lungs and stuff, or to medicine, to freaking wheelchairs, to freaking cars, to car parts, or to electronics, or whatever. Material engineering basically, my favorite stuff has always been biogenetic engineering, quantum physics, quantum mechanics, and quantitative math and chemical engineering. Everything else has just been fun, but material engineering has been going back in those top three favorite spots due to what it holds, the position of high importance it holds as. Most of the stuff cannot be made while someone's making the smallest portion of it first. So, anyway, this is the overview.